say it's this red region that we want to revolve about the line y equals -1. In part A, we want to use, with respect to x, which means we want to use the washer method, because when you use the washer method, you want your typical washers to be perpendicular to the axis of revolution. On the next board, we'll look at the shell method for calculating that volume. So here's the formula for the washer method. Won't go into where that formula comes from, but pi times the definite integral from a to b. In that case, it's from 0 to 3, because these washers are piling up along the x-axis. So we're going from 0 to 3. Now the outer radius is the distance from the axis of revolution to the outermost part of the washer. Well, this is a vertical distance, so think of it as the y-coordinate at the top minus the y-coordinate at the bottom. That will give you the height, or the outer radius, for a typical washer. So the y-coordinate at the top is x squared, minus the y-coordinate at the bottom is always -1. So it's minus a -1 or plus 1. That right there, for any x in this interval from 0 to 3, will give you a formula for the height, or the outer radius, of a typical washer. Now we have to square that. There's the outer radius squared minus the inner radius squared. Well, the inner radius is just the distance from the axis of revolution to the function that helps create the hole in the washer, and that's this distance right here. So the y-coordinate at the top is always 0, 0 minus a -1. That inner radius is always just a 1, 0 minus a -1 or 1. And of course, we want to do this all with respect to x. Now, to get the exact volume, you'd square this binomial, subtract this 1 squared, find the antiderivative, evaluate from 0 to 3, multiply by pi. For the shell method, we want to use this formula, 2 pi times the definite integral from a to b. And because our axis of revolution is horizontal, then our typical shells have to be parallel to the axis of revolution. That's how the shell method works. That means we want to find this height right here for a typical shell. And that's x-coordinate at the right minus x-coordinate at the left. Okay, so for each of these y sub 1's from 0 up to 9, if we want to get the x distance in terms of y, we have to take the square root of both sides. So normally we would say x equals plus or minus the square root of y. But we're dealing with the positive distance right here. So this little green distance right here is 3 minus y to the 1/2 for every y between 0 and 9. So here we go, 2 pi, the definite integral. Our shells are piling up from 0 to 9 along the y-axis. The height of a typical shell is 3, the y-coordinate, or the x-coordinate at the right, minus the x-coordinate at the left. 3 minus 1/2, y to the 1/2, I should say. The average radius is the distance from the axis of revolution to the center of the shell. Again, that's a vertical distance, so it's the y-coordinate at the top minus the y-coordinate at the bottom. Well, the y-coordinate at the bottom is always a -1, and this distance is y for every little shell that we create, So it's y minus a negative 1 or y plus 1 dy. Okay, and if you evaluate both of these, you'll get the same answer for both. Okay, I'll post a link to the Desmos graph that contains the answer. Try to work it out and then check your answer with Desmos.